I request all to assemble inside the auditorium. Good morning and a warm welcome to one and all. We are gathered here today to celebrate Foundation Day of CSIR-SERC. I request our director to invite our chief guest and guest of honor of today's function and other dignitaries to adorn the dais. Let us all rise for Tamil Thai Varthu.
நீராறும் கடலொடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் வதனமென திகழ்பரத கண்டமெதில் தெக்கனமும் அதிர்சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகம் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
We will begin the function with lamp lighting ceremony as a tribute to the goddess of knowledge. I request all the dignitaries on the dais to light the Kuttu Velakku. We are very privileged today to have our chief guest of today's function, Professor V. Kamakoti, Director, Indian Institute of Technology, Madras. Guest of honor, Professor Nagesh R. Iyer, Dean and Visiting Professor, Indian Institute of Technology, Dharwad, and former Director, CSIR-SERC. Dr. N. Gopalakrishnan, former Director, CSIR Central Building Research Institute, Roorkee. Dr. N. Anandavalli, Director, CSIR-SERC and Coordinating Director, CMC. Dr. H. Bharat Kumar, Chief Scientist and Advisor Management, CSIR-SERC. Dr. G.S. Palni, Chief Scientist, CSIR-SERC. All the invitees, scientists and staff from CSIR family, I welcome you all to the 59th Foundation Day of CSIR-SERC. CSIR, Structural Engineering Research Center, one of the premier laboratories and the Council of Scientific and Industrial Research, was established on 10th June 1965. I now request Dr. N. Anandavalli, Director, CSIR-SERC and Coordinating Director, CMC, to deliver the welcome address.
It's my honor and privilege to welcome Chief Guest of today's function, Professor Kamakoti, Director, Indian Institute of Technology, Madras. And it is my pleasure and honor to welcome guests of honor of today's function, Dr. Nagesh Arayar, Dean and Visiting Professor, Indian Institute of Technology, Dharwad, and former Director of CSIR-SERC, and Dr. N. Gopalakrishnan, former Director, Central Building Research Institute, Roorkee, and former Chief Scientist of CSIR-SERC, Dr. Bharat Kumar, Advisor, and Dr. G.S. Parani, Dr. K.J. Sriram, Director, CLRA, Dr. Ramesha, Director, SICRI, our seniors who are here to shower their blessings, as well as well-wishers of CSIR-SERC, heads of the laboratories, scientists in charge of the participating units of SICRI, CIRI, CSIO, NEEDI, and NML, present media, my dear brothers and sisters of this campus, Vanakkam and Namaskar. So now I request Dr. G.S. Parani to honor our chief guest with a shawl. Welcome you, sir, for sparing the time amidst your busy schedule. Now I request Dr. B.H. Bharat Kumar, Advisor Management, to honor our Dr. Nagesh Arayar with a shawl. Thank you, sir, for sparing your time here and accepting our invitation. Now I request Dr. G.S. Parani to honor Dr. Gopalakrishnan. Thank you, sir, for accepting our invitation and gracing the occasion. Civil engineering is the way of life. It's all about planning, teamwork, experience, and preparing for the unexpected. Structural engineering is the art of using materials that have properties which can only be estimated to build real structures that can only be approximately analyzed to withstand forces that are not accurately known, so that our responsibility with respect to public safety is satisfied. So structural engineering deals with the application of scientific knowledge to develop and improve infrastructures such as buildings, bridges, dams, roads, railways, and common utilities. Therefore, role of structural engineer exists in every walk of life. Infrastructure is the backbone of any nation's economy, and it is important to provide structures and utilities to be safe, while solutions need to be environmental friendly, efficient, as well as economical. So CSIR-SERC was built upon the far-sighted vision of G.S. Ramaswamy with an aim to have a self-sufficiency in structural engineering skills, and was established on 10th of June 1965 as a national laboratory under CSIR. Throughout the journey, CSIR-SERC has been contributing in solving structural engineering issues. To name a few, high-strength deform bars aiming at import substitution, pre-stressed railway sleepers towards green solution, aerodynamically shaped cyclone shelter adopted for Odisha super cyclone, which is saving more than 40,000 lives. And scientists of CSIR-SERC are focusing their research on 4 thrust areas: structural health monitoring, disaster mitigation, advanced materials for sustainable structures, special and multifunctional structures. They provide solutions to industrial needs, such as those to NTPC, BARC, BEL, HAL, railways, and many more. There were a number of technologies developed by CSIR-SERC, starting from TMT bars and precast railway sleepers in the first decade to emergency retrieval system, textile reinforced concrete products, portable, lightweight, foldable module, energy dissipating, replaceable fuse links for steel beam column connection, geopolymer products, laced composite system, adding to the patent portfolio a number of technologies in pipeline, such as geopolymer foam concrete technology, conductive cement, composite embedded sensors for dual sensing of static and dynamic monitoring in structures, laminated vibration isolators with magnetorheological elastomers. So our research contributions enter into practice indirectly through the various codal provisions. Our scientists are members of many of the BIS committees relevant to structural engineering and working groups towards the revision of codal provisions. Towards capacity development, CSIR-SERC organizes and continues to organize a number of advanced courses and webinars on topics covering wide spectrum of structural engineering. Also, we are trying hard to attain our goal of being self-reliant through external cash flow. The center registered an impressive external cash flow of rupees 17 crores during April 22 to March 23, earned through contract R&D consultancy assignments and technical services. CSIR-SERC had intervened through their expertise in solving a number of challenging engineering problems. To name a few, health assessment of dam structure using acoustic emission testing, an advanced NDT for Polavaram irrigation project, structural adequacy of steel concrete composite railway bridges, and attractive or braking efforts for RDSO, identification of defects of honeycomb composite panels by lamb wave propagation technique, and hydrostatic pressure studies were successfully carried out for the first time in the country on carbon fiber reinforced plastic sandwich segments to evaluate their structural performance. These composite segments are meant for constructing sonar dome, a critical component of a warship, which houses the sonar. Simultaneous slosh and vibration studies were carried out on external auxiliary fuel drop tank of light combat helicopter. These studies were highly challenging and were successfully carried out for the first time in the country to evaluate the performance of the tank and qualify for its functioning in LCH. Detailed investigations of vibration of TG foundation supporting structures, including condition assessment in all 4 units of Kameng hydropower project Arunachal Pradesh. These are few which I would like to highlight, but there are many more. And we have completed the 1 week, 1 lab campaign, which is an initiative of CSIR with the aim to showcase the legacy and technological advancement of the 37 laboratories. And this was organized from 5th June to 9th June. And 5th June, we had the Society Connect to showcase research contribution of SERC for the benefit of the society at large. And in this function, Shri Desh Ratan Gupta, Principal Chief Engineer, Southern Railway, was the chief guest, and USP Yadav, Director General, Southern Region, BIS, was the guest of honor. And we had the workshop on technological interventions for societal needs, followed by panel discussion on building quality infrastructure for sustainable society, way forward. And an exhibition on the contributions of CSIR-SERC was inaugurated, and the focus of the second day's program was on the Stakeholders Connect, where we need to understand the requirements of the stakeholders and to collaborate with them for technology development and commercialization. And Shri UK Bhattacharya, Director Projects NTPC, was the chief guest, and Dr. Govindaraj, Head R&T, L&T, was the guest of honor. And 2 MOUs were signed during the function, and panel discussion on roadmap for future was organized. And the third day was on the Students Connect program, and with the aim to inculcate scientific temper and provide a platform to the school children, particularly government school children, to interact with the scientists. Professor Usha Natesan, Director, National Institute of Technical Teachers Training and Research, was the chief guest, and budding scientist competition was organized, and nearly 20 schools participated in this, and hands-on demonstration Build the Right, one on the smart bridges and one on the smart buildings, was organized. And I would like to particularly thank Dr. M. Saravanan, FFL, and his team consisting of AK Farvez Ahmad, Saravana Kumar, Sunil, Vinod Kumar, for making ready the models. These models had sensors that could measure the response under the loading, and the students were very much excited in doing this hands-on session. On the 4th day, we had the Future Entrepreneur Connect with the aim to encourage the engineering students to take up entrepreneurship as their career. Sri Suresh Krishan, MD Isha Homes, and Sri Udayanand, MD Niketa Construction, were the chief guests, and they shared their experiences as entrepreneur, and the students were given, there was a competition among the students, and they have to give the startup or innovative ideas. And the Public Connect was organized with the aim to reach out to the public by roadshows and exhibition, and it was flagged off on 5th June. And the team traveled to Tiruchirappalli, Madurai, Coimbatore, Salem, Vellore, and finally 9th June, a team went to Anna Centenary Library and Science Center to reach out to the public. And the Public Connect was very well received with the 200 plus participants at each place, wherever they have gone. And I would like to thank Srimati N. Ramya and Ms. Renuka Dushankar for their professional comparing. And also thanks are due to Ananta Krishnan, who has made the videos today we will be displaying from each day's event at a very short duration. He has compiled it. And also Ms. E. Surya, who has made the video for the Public Connect events. So if I had to thank, I have to read out the staff list of SCRC because each and everyone had contributed one way or other. So I would like to congratulate, and I'm proud of my team who has such a coordination. This is well executed. And my job was only to present on the stage every day and give some few words. That's what I was done. And this gave me a lot of confidence, and also my energy level increased manifold. And today is a day, as we cherish our achievements, we need to put out ourselves at a much higher platform so that we'll become global benchmark. We need to be competitor to ourselves. And my dear brothers and sisters of this campus, a person with a far-sighted vision, Professor GSR, had founded this campus, and former directors, Dr. Ramaya, Dr. Raman, Dr. Apparao, Dr. Lakshmanan, Dr. Nagesha Rayar, Professor Santosh Kapuria, and staff members have made a strong foundation upon which we stand today, and it is our duty to pay our tribute to them by keeping the campus vibrant with our outstanding scientific contributions. And I'm confident that with such smart people, simple and systematic, manageable and mindful, adaptable and active, realistic and resourceful, trendy and time-conscious, this will happen and continue forever. Once again, I welcome you all for the 58th Foundation Day celebration, as well as the birth centenary celebration of Professor GSR. I thank the chief guests and guests of honor for accepting our invitation, and also my seniors who are physically and virtually present for gracing this occasion. I would like to conclude with the Tirukural, Enniya Enniyangu Eidu Enniyar Thinniyaraga Perin, which means that if those are confident on what they are doing, and if they have persistence in doing, they can do whatever they desire. Thank you all.
Thank you, ma'am. Our beloved director, madam, briefed regarding the 1 week, 1 lab, following which we would like to show a glimpse of the campaign through a short video. request Dr. H. Bharat Kumar to introduce the chief guest of today's event.
Respected dignitaries on the dais and off the dais, good morning to all. It's my pleasure to introduce our chief guest, Professor V. Kamakoti, Director, IIT Madras, Chennai. Professor V. Kamakoti received his MS and PhD degree in Computer Science and Engineering from IIT Madras. He joined the faculty of IIT Madras in 2001 and took over as its directorship in January 2022. He specialized in the area of computer architecture, information security, and VLSI design. He heads the microprocessor development program and the information security education and awareness program at IIT Madras, funded by the Ministry of Electronics and Information Technology, Government of India. He is a member of National Security Advisor Board and member of CSIR Society. He was also the chairman of the Artificial Intelligence Task Force constituted by the Ministry of Commerce and Industry, Government of India. At IIT Madras, he has served as chairman JEE and as associate dean industrial consultancy and sponsored research. He has over 150 publications in international journals and conferences, and he has guided many research scholars and for their PhD and Masters of Science by Research program. He has coordinated and successfully delivered close to 50 projects from industry and government of R&D establishment. He serves in technology committees and National Stock Exchange and Reserve Bank of India. Dr. Kamakoti is the recipient of DRDO Academic Excellence Award, Indian Electronics and Semiconductor Association Techno Visionary Award, Abdul Kalam Technology Innovations National Fellowship, ACCS Lifetime Achievement Award, IBM Faculty Award, and Weiswick Industrial Research Awards. May I request Professor Kamakoti to deliver CSIR-SERC Foundation Day's special address. Thank you.
Friends, a very good morning, and I'm very happy to be here. My relationship with SERC started during a project called NP-MAS, where we were doing structural health monitoring of steel railway bridges. So I was interacting with Professor Saravanan of Civil Engineering and a lot of people from SERC. There were two components to that project. One was structural health monitoring of the roads and the steel bridges. So I'm familiar with a few strain gauges and the accelerometer and connecting them. And that time we did have a challenge of internet connectivity. It was a bridge in Nagari, and when we started installing these systems, we had a lot of challenges. A very interesting challenge that I wanted to tell you today is that for the strain gauge and the accelerometer that the sensor that we put there, there was a foreign unit which had around some 10 to 15 strain gauges and some equivalent accelerometers. And we were trying to measure. At that point of time, for some reason, though, that device did not have what you call as a surge protector. And we realized in Indian Railways, the supply is on the top, while the ground is on the track. And there was some train which actually was speeding on the bridge. They applied brakes, and there was a huge surge current. And suddenly, for first few trains, we were receiving data sitting at IIT Madras, and suddenly data stopped coming. So we went the next day to open up, and then we saw smoke. Okay, then they said that for servicing this particular component, we have to send it back to some Australia. It will take some $20,000, etc. That was a motivation for us to basically design our own simple gadget, which will have a small processing unit and an interface, an AD converter, and an interface to both the strain gauge and the accelerometer. So we made a very small one. We spent around 1.5 lakhs or so. Then we made 10 pieces of that. Each piece, even at a prototype stage, was around 2,000, 3,000 rupees. Then especially for the surge protector, where they said it will be $50 per protector into some 20 sensors, we just put a Zener diode, which was 50 pies, and then assembled this system. Then that time Reliance did have a good, I still remember, had a good connectivity at that bridge. And then we started measuring. Around 1 month, this entire system worked. And that is where I started believing that we need to make systems for our country. We should not rely upon foreign components. And when we start doing, it is not just the cost, it is not just the flexibility, but it is also very important that we can make things that are customizable to our own needs. And the notion of Atmanirbharta came that time. So this is somewhere around 2013-14, and then we demonstrated this. And also, we got a couple of PhD students working on this concept. And that was my introduction to SERC, where we did have a lot of meetings here, and very happy that today our relationship between SERC and IIT Madras has gone to a very good strength. We find almost every day we find some scientist here, there, and some professor from there here, and that really, and we are also literally neighbors, and I'm sure we will continue this in years to come. With these few words, I just thought, as a computer scientist, how do I look at structural engineering? And had certain thought process. I just thought, I'm sure I'm talking about swimming to fishes, but just whatever came in my mind, I'll just present here, and please point out if I'm making some error. But I'm sure there is something that we can discuss together and take it forward, as a country needs lot more of innovation in the area of construction. This is also my active campaign to keep a civil engineer in the civil engineering discipline. Today, I work in the area of computer architecture. We make microprocessors, a very exciting field. But I find it extremely difficult to basically get a student to work with me today, even in computer science department. Then my sort of competitor was AI and ML. Now when I go and talk to the AI ML person, he says it's extremely difficult to get some good student because everybody wants to do quantitative finance and high frequency trading. Okay, so now I have a biological scientist who ultimately lands up as a high frequency trader, and what sort of contribution that we get by educating, spending 4 years in the undergraduate program, and teaching them, setting question papers, and having a curriculum, running a department worth crores of rupees, and ultimately to train scientists who finally does high frequency trading. So there is an imminent necessity for us to keep the civil engineers in civil engineering with lot more of the recent advancements to keep the field exciting. So one of the things that we are trying to do, as I was also very happy when I saw the video, is to give a notion of entrepreneurship, wherein we say to the kids, hey, you have an idea, it is your idea. So I think that will be much more attractive than the pay package which the high frequency trading can give you. So there is a necessity for us today to make our fields, respective fields, very exciting. So just on the lighter vein, I started working on computer architecture for edge intelligence, machine intelligence. Now I see some 10 more students coming to me. So this is the way we evolve our fields. And I thought some evolution that we can bring together with IIT Madras and SERC and many more CSIR labs and other academic institutions. I thought I can put those thought process as a small presentation today. So the old paradigm today was, everything needs to be calculated. So we can have the term called calculability, right? So whether my foundation will withstand a seismic stuff, whether the rod can withstand this much stuff, whether this level of lintel or, centering is enough. So everything was calculated. And unless I can calculate, I cannot design, I cannot build, I can't maintain, I can't manage. So these were the old times. And many of this still today exists. Today when I go in for a structural evaluation, yes, there is a lot of calculation. There are a lot of things that we need to do. And there are many formulas and many mechanical engineering inspired concepts that have come to civil engineering and vice versa, aerospace inspired concepts. But then from that particular mindset or the paradigm, now we are moving towards what we see on your right hand side, the recent trends, where we are looking at digital technologies, specifically building information modeling, where we have several tools today which are basically trying to make a digital twin of a building and allowing us to do a sort of a what if scenario, what if I change here, what if I do here, etc. The advent of Industry 4 essentially implied a Construction 4. Many people say Industry 4 applied to construction is Construction 4. In my opinion, there is much more than that, what we see here. We have a very deep penetration of cyber physical systems, specifically in the area of structural health monitoring. There is also a lot of innovative technologies and materials that are coming up, and new construction techniques that are coming up. As we see, we are very matured in terms of 3D printing. We just have started day before yesterday 3D printing of our guest house. We had a very small house which was 3D printed by one of our startups. I'm sure there was a lot of debate and discussions with CSIR-SERC and IIT Madras. But now we said, can we build a 3-floor building, G+3 floor building using 3D printers? And yes, we have started. And there are a lot of construction materials, the prefab. We are now discussing with L&T to see if we can build a 2,000-seater hostel in 6 months. So there are a lot of prefab, customized construction that we can do. So a lot of things are happening on that front. And we need to understand what is it. So from a computer scientist perspective, what I mean by cyber physical systems and what are the important things that we can do with this large data is what I thought I can make as a presentation today. So the demands now are new construction techniques. We want to now go and build something at Ladakh, and we want to inaugurate it within the next 6 months. And now there are some very small packets where we can go to that 4,000 feet altitude. So where do we do, how do we manage this entire construction, what sort of materials we need to put? There is a carbon net zero area, and what is it that we want to do? How do we make these buildings green? And what are the sustainable architectures? There is a need for low temperature, high temperature, so two big variants that we need to account for. Disaster risk reduction, specifically in seismic zones, how do we make those? And what are some of these innovative technologies and materials? And importantly today, forensic engineering and damage is coming up because today we have much highly technical interventions into insurance. If you want to insure a building today, I'm sure days are not far off that the insurance is applicable only when your building is green, only when you're meeting certain sustainability index, and only when there are certain building management systems which can forewarn certain construction issues. So forensic engineering, like it's a black box. What is a black box to the aeroflight? There needs to be a black box to every construction which logs in many of this data. And I'm sure days are not far off that we are going to look at forensic engineering and damage detection. So friends, these are some of the thoughts that came into my mind, and I'm sure there are a lot more things to come. But this is what, as a computer scientist, I could imagine about what structural engineering can offer from other disciplines that we are looking. But friends, that what I'm also looking here is this area is now becoming completely interdisciplinary, and there is no notion that I am a civil engineer, I am a computer scientist, will never take us anywhere. And the notion of departments, I am slowly trying to motivate IIT Madras to say, let us close all departments, have one school of engineering where anybody can come and start working together on problems of interest. So this is the massive interdisciplinary platform that is today open to all of us, and I'm sure, I just wanted to give some thought process that I have in some of them that I have listed here. Now, when we just look at the whole design aspect, we have now reached a stage where we are using augmented reality, virtual reality, and mixed reality components of digital technologies, and these have a lot of things on many of the points that I have listed here. One is aesthetic. So we wanted a sports center. We are just now building a sports center which should be ready in 4 months using prefab. And the moment we gave some idea, I thought it will take, say, a month for them to come out with a 3D walkthrough. But no, it was just that within 1.5 days, the architect was able to do a fabulous 3D walkthrough, which essentially says this is how your center will look like. And then we were able to quickly go and change many of those things. The next important thing is the sustainable development. We are now in a point to have a digital twin type of an environment, which can basically today look at what are all the important aspects that I would like to add into the design so that it becomes sustainable. And again, model it and visualize it in a very realistic way, very close to reality, and see how this works. And smart growth strategies on buildings and cities. So today there are digital twins of cities today. In the COVID time, one of the major effort that happened, which actually challenged many of the supercomputers in the world, was to model one of the cities, I think New York or Washington, of how COVID spreads inside the city. So can I have a digital twin of a COVID pandemic spreading model of a city? Depends upon how traffic moves from one part to another, etc. I think this is also becoming a sort of a virtual reality today, where we can actually project the growth and see how concretes build up, what would be the impact in, say, even water distribution or water levels, etc. So I think that is going to be an excellent sort of, and how ultimately, as a structural engineering, how should I plan the city is going to be a very interesting stuff. And of course, a lot of automation today can be pre-planned by having this type of visualization. And of course, immersive interactivity. Today, people also sell flats today by giving a metaverse, by saying, go into the flat, see how it is, open the window, how it will be, how the kitchen will look, etc. And this immersive interactivity is also becoming here. And then, of course, the multi-perception. So these are all some very interesting interventions of computer science, and of course, with a lot of architecture, art, creativity, and many more things, and animation, that really can inspire today the construction of buildings, selling of buildings, pre-planning for the construction, etc. Sorry. The next important thing is the building information modeling, and as we see, there are 7 dimensions to this. Sorry. The 2D and the 3D, we are having detailed design, and this existed quite earlier. But today we are having a lot of analysis that we can do in the area of after we make a building, and there is a lot of parameters that we can play with, and a lot of what-if scenarios that we can simulate, and that adds the 3rd dimension to the building information modeling. And of course, the 4th dimension is the construction scheduling. I'm sure there are a lot of teams that are working across India, and specifically in ACRC and IIT Madras for sure, I know, where we are actually scheduling the construction. Now we have taken up a good project. For example, we have taken a project of 2,000-seater hostel, which we plan to build it in 8 months. It normally would be 4 to 4.5 years. Now, how do we schedule this construction is going to be a very interesting thing. And this is the 4th dimension that comes in building information modeling. The 5th dimension actually comes in cost estimation. Today we are seeing, even with some small interventions of proactively looking into the data, our deviations are reducing. So one of the important things where everything happens in construction, somebody said, I asked one of the administrators what it means to have a peaceful director life. He said, don't build anything. Okay, so and the real corruption and everything, every audit objection, everything starts when you have deviations, right? And now, how do we avoid deviations? How do you avoid deviations in terms of the plan that comes from your initial parametric data, and how do you avoid deviations in cost escalation? It comes from your fifth dimension of the BIM is the cost estimation. And of course, there is a lot of things that today we have to do with respect to sustainability and life cycle costing, in the sense that what will happen after 6 years? So today I'm taking a prefab type of construction versus a traditional construction. Of course, I'm going to get a lot of blue points in sustainability. It's going to be much more greener. I can see normally what happens is director number X initiates the project, X plus 1 carries out the project, X plus 2 cuts the ribbon. Okay, and the director's term is typically 5 to 7 years, right? Now, can the director X himself initiate the project, finish the project, and cut the ribbon? So what is this? Yes, it is going to be possible when I have certain types of prefabrication, etc. But what is the cost of it? Will be that director X plus K has to redo the entire building, and what is that K? Right? So these are some very interesting questions. So if I go for prefab, one point, I'm sure it should be a company working with conventional concrete says, sir, in 20 years, I promise it will fall down. But I can't even see what the 20 years is, right? So the other fellow says, okay, sir, it will exist for 70 years, and by the time any concrete fellow will collapse. So we need to have such type of understanding, and that as the sixth dimension. And of course, the seventh dimension today becomes extremely important, is facility management. And that is something, especially when we have highly automated building and something fails, then it becomes a disaster. So if something is not there, we know how to live without it, but something is there and suddenly gets out of our life, and that becomes an extremely complex affair. So these are the very interesting 7 dimensions that we have in building information modeling, and everywhere I'm sure structural engineering will have a very important role to play. So today we are looking at, so some of the things that come out of these 7D are digital twins. I have a digital twin of my building. Whatever I'm trying to do on that building, I first do on the digital twin and see how it is behaving, and then go there. This gives us a quick way of analyzing data. There are ways today that I can do an accelerated live testing also on the digital twin, and that is something becoming extremely important. And then there are a lot of performance simulation, which is basically based out of data. So one of the good thing about construction, I feel, which is much better than even health and agriculture, that we have much more structured data that is available, just because we have been doing simulations and trying to see how our simulation actually performed on the field. And because of that, I feel that we have a lot of data, and these data can essentially influence a building of an artificial neural network or a machine learning paradigm, which can basically help us specifically in the area of building performance simulation, performance of concrete, performance of whatever, steel, etc., in terms of the different parameters in which we evaluate them. And last, there is a lot of intervention of Internet of Things and ML in the edge of these devices, specifically from an energy management perspective. Friends, I must say that today there are at least 2 to 3 startups who had come to me and who had demonstrated in multiple large installations that with some minor interventions, they can save up to 30 to 40% of the power consumption, with just minor interventions. We have done it on a milk factory, we have done it on multiple hospitals, especially hospitals, and this is phenomenal, and that is something that we need to look at, and when we start constructing, we need to give provisions for this, and by giving these provisions, we should not create so many ducts that will make the building structurally weak. So these are some very interesting things that come up here. So this is one very important aspect that we are looking today, the intervention of cyber physical systems along with the building information management, information modeling systems, BIM, which in my opinion is construction 4.0. So there is a lot of data that is being pumped into BIM, But when we look at on the left-hand side, your left, what we see is a physical system. That is something like today, we are now maturing in terms of building AI models or machine learning models. And what we see is, today there is an instruction giving what you see on the physical side, where there is an human interaction, where today we said, tell the mason, hey, pour this much amount of water and see how the concrete is behaving, right? And then, so that basically he pours water, and then there is some data which is measured through a sensing layer, and that data is basically fed into your cyber system, and then the cyber system does some computation, and then now finds out, okay, this is some more things. So this is not sufficient as per my model. Let us do something more. And then there is an actuation layer, which again goes back to the physical layer. The person will say, pour more water, or in the next column, pour lesser water. So this type of a very, very close-knit feedback system is something that is going to help us build large-scale models which can monitor as and when we are even constructing the building. It will be a regular feedback on a daily basis, where we keep reconfiguring ourselves to the final need or final objective of the building in terms of different parameters. So this is where the cyber physical system and the human interaction are going to happen for quite some amount of time till the AI models stabilize or data stabilizes. And this, when integrated with the building information modeling systems, the 7 dimensions, I think that is what I feel will be construction 4.0. Now, some of the very important components that are going to come here, especially where we can employ the left-hand side in a much more detailed way, is one is industrial protection, where we are looking at prefabrications, we are looking at 3D printing, and everything at offsite. Today, many of our projects are getting delayed. We have been blaming CPWD, but the essential reason is there is no labor, right? So we are not getting labor, and labor is becoming a very big problem. And so the way we look at it is to have prefab constructions and bring it out, and that is going to become extremely important. And the more important thing here is that we are also looking at, for example, in COVID, we suddenly needed 3,000 beds, right? And then, yes, there was a startup from IIT Madras, Modulus Housing, which was able to create that 3,000 beds within a period of 30 days. Right? And so this all comes from this type of prefabrication. And it's not just beds, but it is oxygen-enabled, ventilator, fixable bed, which is very easily doable today. And so that is another very important aspect, which is going to be influencing your cyber-physical system. And when we come out with this prefab configurable structures, I'm sure there is going to be a lot of cyber-physical interventions and a lot more data and customization that will happen. The next important component here are the cyber-physical systems, which would be actuators, sensors, IoT, robots, and cobos, which are basically collaborative robots, and drones, which are basically going to do an aerial survey or even closer survey. They can also, do a non-destructive testing of your concrete to see if there are pores or if your strength is high, and a lot more that we can do just by these cyber-physical systems, which can also be part of your essential construction, basically giving you the structural health on a day-to-day basis of whatever you have constructed so far, and also predict that if you go in this direction, this would be the health parameter, and you can keep changing. And there are a lot of digital and computing technologies like laser scanning, reality capture, and simulation, which will make this a much, much more robust platform down the line. And the very important one, I'll just finish in the next 5 more minutes. The very important thing is to find out the root cause of failures and resulting responsible entities. And we need to quantify the extent of damages, and we need to demonstrate and illustrate on how the file system should be repaired, replaced according to best practices and our codes and standards. This is a direct practical relevance, and this has an implication today in insurance claims. I'm not really, I will not be surprised that within the next few years, they will say that if you are going for a loan for construction, today already there should be a fire safety norms, but that is just going to be, a very simple aspect. That itself, many buildings are running from pillar to post, but we will now get much more than that in terms of how much are you monitoring, how much are you continuously evaluating the parameters and what are the sustainability that are there. Is it giving you enough electricity? It's not just the FSR or the OSR space that you give, but it is much more than that. And there will also be a very important component. I have no doubt that we have to start seriously looking at forensic engineering as a part of our entire building process. And that will be a responsibility of structural engineers rather than other people like construction material or other type of civil engineering expertise. The very important things that are coming out are about resilient infrastructures, specifically looking at green and sustainable buildings, that there is a circular economy model that we want. How do concrete, when concretes are destroyed, how this concrete, can it give you new can it be used for making the next generation concrete? Can I recycle all these building waste? I just visited Adayar Punga yesterday, and I know that 20 years or 14 years before, it had 60,000 metric tons of building concrete demolished and put at that place. 60,000 metric tons which was removed. Okay, and I'm sure many of you would have visited Ghazipur to see much more of that. Right, so there is, friends, we can't go like this, and there needs to be an end to this, and I'm sure these are some very important efforts. Then alternate materials for construction, like self-healing concrete, graphene, carbon fiber reinforced concrete. We have done something on GFRG and so many things. And of course, the structural health monitoring, which is going to be with embedded sensing today. So when the previous metro was dug, entire Mount Road actually reported saying there was some shiver in the buildings. And then everywhere we had to take our this accelerometer and then measure the shiver and then certify nothing will happen. So there's one, I still remember some 7-store, that guy really got panicked at night, 10 o'clock, and said, can you bring that 1 o'clock in the night? Right? So I think these are very, very important as we start doing more and more structural health monitoring. And yes, this is the entire cycle. We see structural analysis leads to structural design, which again pumps back to structural analysis. Structural construction leads to structural operation and maintenance, which again influences structural construction. Structural integrity leads to structural health monitoring, which again pumps back to structural integrity. And sustainable materials lead to sustainable structures. Again, we go back to by evaluating. So this closed cycle, these are the complementing macro components of structural engineering. But this cycle needs to close, and there is a lot of big data that is going to play a very important role of, I do an analysis of a design, and the design is actually in place. How does it influence my future analysis? I do a construction, and that is being the entire operation and maintenance is happening. How does it influence my construction policies? I have done a structural integrity testing of, say, some bridge, and real monitoring is happening and what went wrong. I have specified these sustainable materials and these structures were made and what is essentially happening. So this cycle has to be extremely influenced, and the role of big data is going to be extremely useful for this. So yesterday's research has catered to today's demands, and what are the future trends in research can we set? And this is going to be extremely multi-departmental. And can we set engineering research directly relevant to immediate ecosystem? And what are those ecosystems? Optimal, quick provisioning of civil structures. This is what COVID has taught us. Today, every director would like to see a building coming up within 5-6 months. So that, if we really think of exponential growth, if we really think of, I would like to do a laboratory very fast, we need good construction. Without construction, nothing can happen. What are the advanced machineries that we can put? Advanced structural science of measurement, metrology. What are the sensors? What are the instruments, data acquisition systems that we can put? And very importantly today, as we see many temples, there are fantastic architectures, 2,000-year-old, 3,000-year-old temples that we see. We also see some heritage building. Can we set trends in heritage structures, maintenance and restoration? I think if India can do, I think this is our really an Indian thought process that we can set the standards today there are some FIB standards I saw on FIB standards for concrete performance, etc. FIB 2020 standards. Do we have such standards in India? I'm not sure. I tried, but I couldn't find. But yes, if there are, then we need to develop and be in trend with what the world has. And resiliency in structure should not be an afterthought. And can we start develop standards and guidelines here? And of course, forensic engineering. These are some of the thoughts I thought we could all have. Thank you very much for this. And I don't know whether I can answer questions, but I'll take questions and keep it in my mind and see if I could get an answer. Thank you very much.
Thank you, sir. Thank you for the enlightening speech. And thank you for highlighting us some of the latest computer science applications such as digital twin, metaverse, cybersecurity systems, which will help make structural engineering with much more ease and robustness. I now invite Dr. G.S. Palni to introduce the guest of honor, Professor Nagesar-Iyer.
Respected dignitaries on the dais and off the dais, my dear colleagues, press and media, ladies and gentlemen, very good afternoon to all of you. It's my pleasure and privilege to introduce our guest of honor, Professor Nagesar-Iyer, fondly called as NRI in this campus, to this august audience. He is not new, he is very familiar to many of us. As the occasion demands, and for the benefit of the staff who have recently joined, I will briefly read out his profile. Professor Nagesar-Iyer, Fellow of the Indian National Academy of Engineering, currently holds the position of Dean Infrastructure Planning and Support since February 2018, along with being a visiting professor in civil and infrastructural engineering at IIT Dharwad. He has played a crucial role in the development and construction of a smart and sustainable permanent campus spanning over 467 acres with a built-up area of approximately 2 lakh square meters. This remarkable achievement was completed within a record time of 3 years, even amidst the challenges posed by the COVID-19 pandemic. The campus has received 2 prestigious awards from the Graha Council for its exceptional master plan and passive architectural design. Professor Iyer's academic journey has been exceptional with a Master of Engineering in Structures and a Doctor of Philosophy earned from Indian Institute of Science, Bangalore. His exceptional research and development contributions propelled him to rapid growth within this CSIR-SERC, where he began his career in 1977. Professor Iyer served as the Director of CSIR-SERC in Chennai and the Coordinating Director of CSIR Complex from February 2019 to November 2014. During this period, he concurrently held the positions of Acting Director of the Academy of Scientific and Innovative Research, ACSIR, and Director of Engineering Coordination at CSIR, New Delhi. His unwavering dedication, discipline, and exceptional performance led to the recognition of abilities, resulting in CSIR assigning him additional responsibilities over time. Upon reaching the age of superannuation, Professor Iyer was appointed as the Distinguished Emeritus Professor of ACSIR for a 3-year term, acknowledging his remarkable contributions. He has traveled extensively abroad as a part of his various programs, including UN Fellowship. During his UN Fellowship, he served as a visiting faculty at esteemed institutions such as University of California, Berkeley, Cornell University, University of Wales, UK, TU Delft, Netherlands, University of Hagen, Forschung Zentrum Jülich, University of Munich, Germany, BMBF, Berlin, Germany, and Poland, engaging in collaborative research and development initiatives. Professor Iyer has played a pivotal role in designing and delivering the courses at the undergraduate, postgraduate, and doctoral levels. He has actively contributed to teaching and renowned educational institutions and has been recognized as a guide for doctoral programs by prestigious establishments such as IISc, IITs, Anna University, ACSIR, and BITS Pilani. He is chairman and member of several national and international committees, bodies such as DST, SCRB, Indo-US Program on Clean Energy, Chairman Indo-UK Program on Initiative to Promote Habitat Energy Efficiency, Indo-EU Program on Energy, Indo-German Programs, mission motivation programs of India with 22 countries. He was one of the key members that released the AICTE model curriculum in 2016. He holds different portfolios positions in several prestigious bodies and organizations such as member and academic council and board of studies, civil engineering of Shastra University, member of governing council, NIVI, National Institute of Wind Engineering, Wind Energy, MNRE, committees of INAE chairman, selection board panel of DRDO for civil engineering. With over 45 years of experience, Professor Iyer has made significant contributions to the field of computer-aided analysis and design of complex and large structures. His expertise encompasses a wide range of infrastructural facilities such as power plant structures, flyovers, bridges, natural drought RCC hyperboloid cooling towers, offshore and ship structures, and critical components of aerospace structures. His research interests include computational mechanics, building energy efficiency, low embodied energy materials, sustainable and engineered materials for construction, performance and health monitoring of structures, life estimation and management, and renewable energy. Additionally, he has been involved in the execution and supervision of large construction projects. Professor Iyer is highly regarded as one of the leading experts in the field of computational mechanics, earned him several awards and accolades. He has been conferred with the fellowships by Indian National Academy of Engineering, INAE, Indian Association of Computational Mechanics, and Indian Association for Structural Engineering. He is also a fellow or member of the other esteemed bodies and agencies such as the Indian Institution of Engineers, India, and Indian Concrete Institute. He has been awarded the Technology Prize by CSIR and received multiple endowment awards. His research papers published in refereed journals have garnered him numerous best paper awards and has authored and edited books and journals holding patents and copyrights of software. Professor Iyer's extensive publications include over 200 papers in national and international refereed journals, with many of them being widely cited. He has also presented over 190 papers at national and international conferences, in addition to contributing over 400 technical reports. Furthermore, he has been actively involved in numerous consultancy and sponsored research programs. Professor Iyer has provided his expertise in proof-checking large project design for review of project and programs across various sectors such as space, atomic energy, defense, construction, and infrastructure. His notable achievements include co-editing a popular book published by Elsevier Science called New Materials in Civil Engineering in July 2020, while another book on green materials in civil engineering, which is under publication. I feel proud to say that I have closely worked with him for more than 26 years at SCRC, and he is also my doctorate guide. We have co-authored 64 publications in refereed journals. With this brief introduction, I request Professor Nageshwar Iyer to deliver Professor G.S. Ramaswamy Birth Centenary Lecture.
I think that was much longer than what I'm going to speak. So, a very good afternoon. Chief guest of today's function, Professor Kamakoti, my colleague Dr. Gopal Krishnan, Dr. Anandwali, Director SCRC, Dr. Bharat Kumar, Dr. Palni, August, my colleagues sitting in the row here, and the directors of other CSIR labs, sister labs, and my dear friends, colleagues, invitees. A very good afternoon. Before I begin, let me congratulate Professor Kamakoti to give a different perspective of structural engineering. I was telling him that I may have to look for another school to learn another area of structural engineering, new way, the perspective. I think it is a very eye-opener for everybody. And I also want to congratulate you, sir, for you and to your team for maintaining the NIRF ranking. Among all the IITs, they are the topmost. And also maintained the second in overall rank. Well, we have not done, we have also done very appreciably very well. The ACSIR stands 12th in the NIRF ranking. So I think that is also something. It's with great joy and pride that we gather here today to celebrate momentous occasion of, will you call Dr. Anandwali 58, 59 or 60? I mean, so Foundation Day of CSIR, SERC, and I'm especially privileged to be part of Professor GSR Centenary lecture. I think it's an honor. This special event holds profound significance as we pay homage to the visionary leader, our first director and the founder director of this esteemed institution. On this auspicious day, we not only commemorate the remarkable journey of CSIR-SERC, I think you would have seen from the presentation and the short video, it's a remarkable achievement. It's a testimony of the past glory that has provided a very good future, and I am sure SERC has a very bright future led by Dr. Anandwali and then the future directors that would come. So we'll not see just the centenary, probably bicentenary, very shortly. Time is very short. We don't know how the time flies. And my colleagues here, Dr. Vaidyanathan, Dr. Srinivaslu will recall it was a very long journey, it seemed. But then it's so short that we are here today talking about centenary year and then going forward. So reflecting upon the achievements and milestones that SERC, I thought, I would make my presentation in two parts. Maybe that would, one is the browsing of whatever happened, during GSR's period, Professor G.S. Ramaswamy's period, and the one that, set standards and also the benchmark, to looking at future. So we could see how, I sent, I think when the celebration, his centenary was opened, the first, living legend, nobody will find a living legend. I think we have been extremely lucky that we had Professor G.S. Ramaswamy in our midst, and I feel extremely lucky that I was one of the last to be selected before he left SERC. So, and one of the chapters that probably myself and Dr. Appara contributed was in the one of the books on the shell structures, which he was very fond of. So maybe I will begin my presentation. How does it go? So here I have put it deliberately, India at 75, GSR at 100, CSIR at 80, and SERC approximately at 60. So that's why I was questioning you whether we call it 58, 59, so take it as 60. So it's little with a pinch of salt. To talk about, Professor Ramaswamy will be too long. This is too short a time to talk about him, but I would like to make a brief capsule of what probably we have all known and experienced when he spent his time as director here. And he was known for many aspects as a visionary leader, and we could see that. So I want to actually show that, what standards he set at SERC when he started looking at SERC with a sort of a vision, which in my opinion, no CSIR lab has attempted and put an effort to set a roadmap of the way he has done it. So I'm not going to read any of the slides. It's only for you, for those who have not been knowing him or heard of him but then don't know the details, you could probably see. But when he became the first director of SERC Roorkee, I just want to show you what kind of a thing was written in the formation, establishment of SERC. See, this is the kind of statement that was given there. At that time, it was called, Board of Scientific and Industrial Research and not Council, okay? And the governing body, they took a simultaneous decision to establish SERC, and that was actually a solo effort, effort by one individual called Professor G.S. Ramaswamy. And I just briefly said that, he joined at the age of 26 as professor after he returned from CIT, California Institute of Technology. You can just see the kind of waves he made and the kind of research this thing he had in his mind, the foresight. That's very important for a leader. So they say that, the team will be as good as its leader. So he has chosen, one among them here sitting, Dr. Srinivaslu and Dr. Vaidyanathan. The book is actually on machine foundation, and today it has been reprinted several times, and that's actually making waves all around the country and internationally that is famous. So that's all because of one of these efforts was Professor Ramaswamy. He could pick and choose scientists. So he was not only a good leader, but he made leaders, created leaders. And this is the kind of, and this I took, from a public domain source when I was the director here. So I had access to various documents. And this is the kind of statement that was given to the ministry as well as to the board, why we should establish a CRC. This was actually CBRI, where he was the head of a structures division. But he thought that this structures division will not be able to fulfill all the demands and requirements, not only of the country, but if we have to be known internationally. So it was that time when we were in a mode of what is known as denial mode. That means no technology would be available to us directly. We'll have to get it ourselves. So he thought about this, and he said, why not create a separate establishment? And that's how the SERC was born. I'm not going to read all over again. These are basically the functions, and I'm sure we have not changed the charter of this laboratory. It is the same charter which we have been following. And just to give you a small idea, at the age of 26, 27, what kind of a chaotic thoughts you get and what you can create out of those chaos. So you can create an order from the chaos. This is one of those examples which is actually standing testimony at Annamalai University when he joined there, and this was one of the first specimen that was cast. So this is something which one can take note of. So that, people could see that there is some, a legend is born, something like that, that showed some signs of good this thing. So at SERC, what he did, the first year, the progress in the first year was outstanding. You could see that he emphasized on technology development and import substitution. That was the buzzword those days, like we call today sustainability as the buzzword. The buzzword then was the technologies and how do you stop this thing. So this import substitution award was one of the first achievement of SERC in the first year. So baby steps, but then still looking like a matured child. So that is something which was, which stands testimony to his name. And of course, there is a very big team. Our Zakaria George and his team, they were all involved. And several new areas were developed. Actually, housing was one of the areas which, it was too early for the country to be thought of, something like that. And it was mass housing. All those words, buzzwords, which we are talking today, were actually in the 60s and the 70s, early 70s. And we are talking about, precious concrete sleepers. So UNDP scheme, it was his idea that why not we take funding from UNDP when we cannot get funding from the ministry because of various constraints. So he developed an idea of why not approach United Nations and get funding and train our scientists. So there was a leapfrog jump in terms of establishing infrastructure facilities at both Roorkee as well as Madras. That time Madras was known as an extension center, and the Roorkee was the main headquarters of SERC. Eventually SERC was transferred to Chennai as its headquarters, and the Roorkee center was closed. But then the UNDP benefit was manifolds. It trained all the scientists here, the staff here. They could get a visit there and get trained at one of the best locations in the internationally that is known, both in academic sense and also in terms of industrial application sense, and also get the best infrastructure. So the facilities we are enjoying today is one of those best. And it was those times he thought of interdisciplinary, multidisciplinary, and translational research. I'll give you an example. This campus was established with only SERC. It was later he thought that why not we have extension centers of 5 laboratories. And that is how the CSIR Madras complex was born. And that helped interacting with various labs. Also, although the parent lab, Centenary or SECRI, etc., they wanted to have an extension here, but then he saw the benefit that would accrue to the CSIR as whole. And that is the kind of thing which we are talking about today. Later on, Dr. Mashelkar came with an idea, along with Professor Kelkar. There was a committee constituted to revamp or re-examine, revisit CSIR, and there was a document which says that why not we start talking about networking project. So initially it was confined to networking of different laboratories of CSIR, And later on, it moved forward to having networking with industrial partners, etc., etc. So these are the concepts and ideas which he created. The other idea was, he was the one who talked about different materials of construction that is to be used. How do we examine different materials? It was not for the sake of talking about materials, but doing something and using it as what is a large-scale application in structural engineering. These are his two famous books, which are being used as not only reference book, but as also textbooks in many of the universities in the country and internationally as well. Just, I stole from our first annual report of CSIR-SERC. You can see the cover that talks about those days photoelasticity, 2D and 3D photoelasticity, probably which we do not talk today. We talk about LIDAR and we talk about drones, etc. In the surveying, they change the syllabus. We talk about those techniques. But then that was the first year, and the first year annual report. See, he could get the best of the people. You will see in many of the photographs, best of the people that came to CSIR-SERC here and visit, and then brief them about its progress and get maximum advantage in terms of funding, etc., and promoting different activities. This is some of the signatures around the world are well known. I mean, this is something, if you see, this is Professor Ramaswamy's signature. That's why I just put it here, that others can have a look at it, how he used to sign them. And that shows all, actually. He's a very, very different person, and it would be extremely difficult to find another equivalent person in this area. And this is what he wrote as a preface of the first annual report. That was on April 5, 1966. So you just see, he talks about ultimate load design. I mean, just trying to, steal some of those words which he have used, time saving and labor saving. We were talking about today labor saving. So, and another thing which probably when Professor Kamakoti mentioned, I just wanted to tell you that, you said that if you want to have have a sleep and no worries, you said that, you should not build anything. There's one more thing which he used to tell, that if you want to be a very popular director, don't take decisions which are abnormal. Okay? Don't risk your profession. So he was the one who didn't care for all this, but of course, without violating any of the rules and the laws. So something like that, that's something, still he could get good sleep. Okay. This photograph is just to show that, it was most difficult to get the time of a planning commission member those days. And here is Professor Ramaswamy just bringing Professor M.S. Thakur and Dr. Atmaram. It's most, you could never get such moments. Most of the institutions will tell you those days that they cannot get such members together and visiting Chennai. Why should they come to Madras? So some of these, moments are actually etched in our minds. I'm sorry, just skip one. It doesn't go back. Anyway, this is Subramaniam. Those days he was also holding the additional charge of science and technology along with agriculture ministry. So here is one of the labs that is created here in HTL. We used to call them those days heavy testing laboratory. Again, see Subramanian here, and what is this? It jumps. I think I skipped one. Right. If you see in the campus, our campus, you'll find some of those exotic buildings. They say that charity begins at home. So whatever research was done here, it was on the insistence of Professor Ramaswamy that you demonstrate. So it is not just the theory, it's not just the computation, it is not corroborating results, but it is going beyond the lab scale. So you don't talk about laboratory. The concept of laboratory doesn't end here. It's a field demonstration within the campus. So I can just take you around a little bit more. These are the buildings that were built in the campus. brick shell roof. I mean, nobody will ever think bricks can be used for roofing, and that too in a form of a shell. Okay, so that is something, there is no reinforcement. The reinforcement is only at the ribs. So this is something unique. Then we talk about this helical dome, spherical dome. There is something unique about this. There was a famous dome those days called Calico Dome. I don't know how many of you know Calico. It was one of the textile industries, and they had their own dome. So this is where, we took up a challenge that we can make a dome like this. And this, the concept, I think one must know what is the concept here. It has got aluminum inside. So it is a very lightweight structure, and how to give a correct radius of curvature, how to make this thing very precise. And that was very, very clearly done by the team that worked on this. So this is something, simplicity, but then still high-level thinking. So this is just one of those examples which you can see. This is another building which exists here. We have again a funicular shell. The funicular shell concept is simple engineering common sense. You hold a gunny bag at 4 corners for your matrix, okay, and then lay it over a mold, and you get this form of funicular shell. So this is something, I'm just talking very simplistically, but it's an engineering design. So there is an engineering design which goes into this. You have that 8th order partial differential equation. You solve it, and then you get, you decide on your thickness of the shell, etc. All those things are decided. So, but then the concept that went in terms of, transferring the technology, those days the skilling was one of the concerns. We don't have a skilled labor, mistri, okay, so mason. So, how to teach them, how to transfer that knowledge, make it very simple. So this was some of the thing that was done by, a team of scientists working with Professor GSR. And these are, you will find many places spread in the campus, hyperbolic paraboloid shell roofs. We have the stores building, perhaps I still remember it is still there, and we have parking lots which are built with hyperbolic paraboloid shells. Okay, there are many advantages of these shells. And this is something very unique, this concept which actually, you can imagine this is the only water tank that is there in this campus, overhead water tank. And this is mimicking nature. This tells that the common sense of an engineer, that the broader the base, the safer it is. And this beats that concepts and tells you that it is still safe and operational, serviceable. So that is the kind of structure. So this is, out of this only the area of biomimicking actually started. This is the catenary shell roof. Again, these are simplistic concepts, but for construction, again using a different hollow, bricks, so you can actually do this. These are all demonstratable, but actually proven scientifically. So, again, you have these all 8th order partial differential equation to solve, and then you get this. This is what probably Anandwali was mentioning. This is the first fly ash building that is there in this campus or in India, in the country. It was actually, Professor Kamakoti, this is 13 years of exile like Ramban was. We worked 13 years to get approval from the BIS to be allowed to be used, fly ash to be used along with cement. And that was a huge challenge. 13 years of dedicated service by the scientists. And then it got into the code of practice, and today this is like a common thing, like pencil pen. So if you talk about OPC or PPC, everybody knows what it contains. It contains only fly ash, and then. But the idea that Professor Ramaswamy was giving was, can you replace, here it is a partial replacement of cement. Today we are talking about full replacement of cement, and because 1 metric ton of cement production causes another equivalent metric ton of carbon dioxide. So this is something, a challenge for the civil engineering and material science engineering scientists. So these are some of the, significant contributions that came out of, SERC in the first 5 or 7 years, I must say, of SERC. And I have listed only few of them, and these are just samples. But it shows the way for future, and I'll tell you how it shows. Recently, we had a meeting in IIT Bombay. So I was one of the members under this Technology Vision 2047. And from the civil engineering side, I was representing, and I was asked. So I had no other choice but to depend and look at Professor Ramaswamy's. So that gave us the lead, how to plan the future, what should be the vision for 2047. You don't directly jump from 2023 to 2047. There are various graded steps, like we have this undergraduate PG program and the doctor and the postdoc. Then you get the faculty thing. So this is the same thing which probably we do, and we need to do a SWOT and all that. So you will find that, directly or indirectly, it is all Professor GSR's thoughts that was seeded those times in 1965, and that has been, that has been taken forward. So this is what we have identified as the priority areas. Of course, this is a draft stage, and then we definitely invite members from everyone to comment and give more suggestions. We can improve upon this, and I'm sure you will find that some of these are repeating from your own presentation. So maybe, but you shouldn't tell me that I have a plagiarism here. So it's a coincidence that some of these thoughts match. And of course, in place of BIM, I have put it as BMS, so Building Management System, etc. So it's in construction 4.0, you have BIM plus BMS. So that is a small alteration which we have done. And what is the existing status? So here, this is what I have put here. If you see, R&D innovative on, what do you call, can you replace fully cement or find an alternative sustainable material? And what is the role of PCM? The PCM is being talked about very recently, just like sustainability. PCM also is another buzzword, phase change materials. Not much has been done at the industry level, actually. This is all in the R&D. And we have actually changed the concept of R&D itself. We say, now we've taken R&D forward, saying that RD and D. So if you find that, research, development, and deployment. So that is the deployment is the additional word which we have made use of in this vision document. We said that nothing should stop at the development level. It should go beyond R&D. So deployment is another important parameter. And we have also committed in the COP 26 and 27 that will become net zero. So we have a mandate on hand, and we should see how we can reach that much before that. And that is what is the aim, which we are working on very vigorously. So this is some SWOT analysis which I would probably skip through because there is a lot to discuss and talk about. If I take one by one, it will take a lot of time. But this is all based on the available data and proven data. So it is established based on whatever facts we have. Incidentally, Professor Khakkar is the chairman for this. So what we did is we split 2047. So how do we reach 2047? So first we go to 2027, and then we go to 2032, and then reach 2047. That's the only way you cannot directly jump to 2040. So because you need to review what you have been doing, all along. And this is what was taught to us by Professor GSR. You take a review, instant review, later review, midterm review, and the final review. So this is how we take the steps, okay, to reach 2047, and we should be able to reach without much of what you call experience of fine tuning. It should be fine tuned at much earlier stages. So this is something which has been worked upon, and we have tried to see how we can deliver the best of things in 2047, where you not only have the net zero, but we also have the constructability, using different materials which are durable, sustainable, and as you rightly said, resilient. So this is something which is very, very important. So this is actually the vision statement, which is again in the draft stage. Comments are welcome. So maybe you should be able to give some more inputs. We can improve upon this. But as it is, this is what was converged upon at IIT Bombay, that we need to work on infrastructure that requires advanced materials with targeted properties. That means you predefine what you need to do with your infrastructure or your buildings, habitat, etc., etc. As the chief guest today mentioned that, planning is very important. So if you don't have a proper plan and if you don't have a design concepts in the beginning, then you end up doing a lot of repairs and it becomes very ad hoc solutions and it may not be sustainable. So we should really work upon targeted properties. So that would define what kind of materials that will go into this. And these materials should be such that they are not only eco-friendly, durability, but what I have not written here is it should not use the natural resources. Today, the challenge is the natural resources are being used left and right, and that is causing a lot of influence on climate change, etc. We are experiencing a result of that. We are talking about M-sand. We are talking about how to use the, you mentioned about precast. I can tell you that precast not only achieves precision, it, minimal waste, construction waste, it generates minimal construction waste. So we must have technologies that would reduce the waste. But at the same time, there are other wastes that are produced in different sectors, which is not a civil engineering sector. The sectors are probably some other sector which are production based. And there, like IBP, industrial byproducts, we are talking about making use of that waste. You have seen recently in Delhi there was a issue of landfill. Why the landfills are created like this? That's because you generate so much waste and you don't know where to dump it. So we should find a way of reducing this waste in the dumping yards and taking it directly to usability. So one of the place that could be used is a construction waste. One of the standing example is the highways and the pavements. There, a lot of waste is being reused. So recycled, construction, demolition. So we are talking about redevelopment of some of the buildings. When we do that redevelopment, we are also generating a lot of waste. So how do we make use of this waste into a usable construction material? So these are some of the challenges. That's what we should be aiming, how to reduce the landfill and how to make use of it in the construction. So towards the end, maybe I would like to say a few things. One is, this is a common thing I just thought to ponder for all of us. And before I end up, maybe I should say on this special occasion, let us remember Professor Ramaswamy's legacy with reverence and gratitude. Let us rededicate ourselves to the pursuit of excellence in structural engineering research, innovation, carrying forward his vision for a safer, more sustainable built environment. May his extraordinary contributions continue to guide us as we navigate the challenges of the future, as we celebrate 59th Foundation Day of SERC and Centenary Memorial Lecture by Dr. Gopal Krishnan. Let us express our heartfelt appreciation to the scientists, researchers, staff, and students, present and past, who have contributed to the success of SERC. Their unwavering dedication and passion have propelled SERC to new heights of excellence. In conclusion, let us renew our commitment to upholding the ideals of Professor GSR and his vision of SERC. Together, we should strive for excellence, push the boundaries of knowledge, and create a future where structural engineering research continues to make a profound impact on society. Thank you, Dr. Anandvalli and your team for inviting me here. I'm really grateful, and it's an honor for me to be here and make this presentation. And let us embark on this journey together of honoring the past, embracing the present, and shaping the future of structural engineering research and innovation. Thank you very much.
Thank you, sir. Thank you for walking us through the accomplishments, ideas, and work of Professor G.S. Ramaswamy, and also highlighting the work to be carried out, which is for a sustainable future. I now request Dr. G.S. Palni to introduce the guest of honor of today's event, Dr. N. Gopalakrishnan.
Very good afternoon to all of you again. It's my pleasure and privilege to introduce our guest of honor, Dr. N. Gopalakrishnan, again fondly called as NG in the campus. Again, he is also very familiar, but as the occasion demands, I will make a brief introduction about him. Dr. N. Gopalakrishnan has done Bachelor's in Civil Engineering at the College of Engineering, Guindy in 1984, followed by Master's in Structural Engineering at IIT Madras in 1986. He joined as a scientist in Structural Dynamics Division of CSIR-SERC during 1987 after a short stint at Tata Consulting Engineers, Bangalore as a design engineer. He has obtained the doctorate from IISc Bangalore during 2008. His areas of research interest include structural dynamics and earthquake engineering, experimental methods in structural engineering, machine supporting structure and soil structure interaction, reinforced concrete structures, structural health monitoring, and smart materials and structures. At CSIR-SERC, Dr. Gopalakrishnan has done many collaborative, grant-in-aid and sponsored projects for industrial and strategic sectors. Notable of them include those funded by National Program of Micro and Smart Structures, NPMAS. I think our chief guest was mentioning about this project. So he was one of the coordinators of this project. ARDB, DST, Rubber Board, BRNS, IGCAR, BARC, NPCL, DRDO, and VSSC. For the first time in India, seismic tests were conducted on the assembled 1:5 scale model of a ground plus 7-storied cold rolled steel framed structure on the 4 meter by 4 meter shake table of CSIR-SERC at ESTAR Lab under his leadership. Similar kind of many experiments have taken place at ESTAR Lab during his regime. I have traveled with him to field visits for failure investigation of collapsed structures. For example, the collapsed slag yard at Vizag Steel Plant, collapsed roof of TG Hall of NTPC Tanda, etc. In such investigations, the challenge is to trace the root cause of the failure in short duration of time. And Dr. Gopalakrishnan, with a strong dynamics background, used to arrive at logical conclusions very fast. Dr. Gopalakrishnan was heading the Advanced Seismic Testing and Research Laboratory, popularly called as ESTAR Lab of SERC, before assuming as the director of CSIR Central Building Research Institute, Roorkee, in 2016 for a term of 6 years. His significant contributions at CSIR-CBRI include reconstruction of schools and hospitals in Nepal, creation of hospital infrastructure during COVID-19, construction of Sri Ram Mandir at Ayodhya, structural fire engineering tests for L&T, creation of construction technology demonstration park at Roorkee, technical coordination of Twin Tower explosion, etc. Dr. Gopalakrishnan has published 77 international journal publications and holds 10 patents. His journal publications have been credited with prestigious Dr. Ramaya's Prize for the best publication for 5 years. He had been UNDP visiting fellow at the University of Michigan, Ann Arbor, State University of New York, Sunny Buffalo, and Cornell University, Ithaca. So I now invite Dr. Gopalakrishnan for delivering the Professor G.S. Ramaswamy Memorial Lecture. Thank you.
Thank you, Dr. GSP. It's a honor and privilege that I'll be talking something about one of our great gurus who has mentored, who has actually shaped up. There are few in this long professional journey of my life who have shaped up the thinking. Like sometimes you don't need to do a lot of thinking. You just follow. Here is a person I'm going to follow. Here is my role model, and one such is Professor G. There are quite a few also, and one such is Professor GSR. The last time we had him here in this particular forum, I think Vivekananda Auditorium was still there at the time. When he came here, I remember only one point which he was trying to tell. I was not appointed by Professor GSR I was appointed by the next director who followed GSR. But then the one thing that he told is, what are you doing about those other 4 or 5 branch labs or the constitutive laboratories here like CIRI, NIRI? I am not seeing a good synergy that's happening. I think this is exactly the word which still rings in my mind. On that last occasion, with extreme wisdom, he was telling, and then that's exactly the direction that we have to move right now in interdisciplinary, and that is being put forth by everyone. GSR also had been a bridge. You come to Central Building Research Institute, Roorkee. It is on the way from Delhi to Dehradun, sir. 30 kilometers from Haridwar, or 70 kilometers from Rishikesh, another 70 kilometers from Dehradun. And then basically like what you see as you go up the stairs of that particular lab, you have photographs of Dr. Dinesh Mohan, someone equivalent to Professor G.S. Ramaswamy there is called Dinesh Mohan, a geotechnical stalwart. And then many of the photographs, including CS and other things, Professor GSR will be there. And some of those things, the kind of vision that the God has given him, the kind of thing that he has given, I'm pretty sure that 50 years, 60 years later, they are as relevant as they used to be when he uttered that word. I also recall one of the things, like 1947 we were created by a group. It is called some building research group or some kind of thing like that. 1947. There were 4 or 5 labs which were established in CSIR in 1947. NPL, NCL, CVRA was not one such, but a small group was established for Central Building Research Institute. I think 4 or 5 of them created that. There was another director and all that. And this fresh, young Caltech graduate was thrilled to be part of that. He was not the leader or all that. And he was the head of that lab called SCRC. We still call this particular lab, there's a big building. The building has still SCRC, it is vibrant. It is still a very vibrant building. There are problems associated with it, but then it's a very vibrant lab. And 1951, Central Building Research Institute got inaugurated. The physical infrastructure of Central Building Research Institute came into being in 1951 by Nehru. Pandit Nehru visit this place. Had been visiting this place 2 times at that point of time. 1951, as well as a little bit prior to that, when the stone was laid or something like this. And then the equivalent of Science and Technology Minister at that point of time is Abdul Kalam. Abdul Kalam, whole lot of luminaries there. I think Dr. Srinivasu will remember all those photographs. And the minister is not only Minister for Science and Technology, but he is Minister of Science and Technology, and guess what? Natural Resources. Minister of Science and Technology and Natural Resources. This used to little bit of worry me whenever I walk around the lab and then see here is a minister who is Minister of Science and Technology and Natural Resources. And then what Panditji tells about that is one of the plagues in we have kept a small stone thing on this. To make use of the natural resources for the well-being of the country, to remove hunger, poverty, so on and so forth. This is what he gives in his particular kind of thing. And then, lo and behold, look at the scenario. When I go into their shoes and think at that point of time, here is an abundant natural resources. We use them. Like Vivekananda used to be thrilled with all these steam engines moving. He used to say, they are so good in technology. We are good in philosophy, but they are so good in technology. When are we going to emulate? This was all the time that king in our mind. Here is an abundant natural resources, like the volume tending to infinity kind of natural resources. Why don't we use it to remove alleviate all the problems? But then sitting 50 years, we were trying to celebrate our 75th year and all that. And then looking back after that, it is not an infinite resource anymore. And natural resource is not there for to be used like you just use it and throw it. It's not going to be like that. It's going to be, we have done enough damage to this, the man as a evolving being has done so much things, like 50, 60 years now or 75 years now, we see that there is the, not light at the end of the tunnel, I will put it something else, that this natural resources is going to be extremely finite. Even if it is like using your stone or fine aggregate or clay or whatever, you are using the least sought after material, but then that is also this thing. So this is how a civil engineer is called upon. The civil engineer is called upon, as you can very well see here. There is a growth happening in some other field, which actually drives your infrastructure development, like tower testing research station. We see tower testing research station, when I joined here in 1987 from Tata Consulting Engineers, I think I remember right, 4 crores was our budget. There is a non-recurring budget, and there is a non-planned and planned budget and all. I remember 4 crores was planned and another 4 crores were non-planned budget, 8 crores. Or maybe it is 2 plus 2, I'm not remembering exactly. We were starting with SERC with a budget of something like 4 or, I don't know, 8 crores or something at that point of time. So now that it has gone to a gargantuan value, but what is that it is bringing forth to the common man is what we need to look at. And the civil engineer has to see, as we look upon the history of SERC, tower testing research station was outsmarting us in terms of earning. Dr. NRI will know that. Something like 1 crore per year was our earning from tower testing research station alone, and there was a move to decouple that as a separate CSS. When something is performing very well, the politicians think that we will decouple that and make a separate lab. Okay? And then they are all because of all those microwave towers and all these great achievement that we are getting in generating our microwave signals. We still remember those days in IIT when all these wireless signal demonstration at IIT Madras. At that point of time, I'm telling you, is such a big, this thing, like they will generate this and then they will keep all those things. We don't understand that, but then that was a gala event happening in IIT. I think you would have heard about that in your school days. But that's a kind of phenomenal amount of development that was happening. And then we just stood by that development. Okay? And similarly, our A-Star lab from where I came from, I'm coming from this lab called Advanced Seismic Testing and Research Lab. We created that lab. That is, we had another guru called Dr. Lakshmanan, who is unfortunately no more. And then, like every building becomes a nightmare of the director. But then, how many buildings, how many labs he has created? Tower testing research station, then A-Star lab, then wind engineering lab. And then there was a galore of this thing, and that's how we are going. And then somebody, we lost one of our doyens, Dr. Madhav Rao. And then he was an expert in low-cost housing. Remember low-cost housing to fracture mechanics. What's the kind of phenomenal quantum jump that the individual has made? And then Dr. Srinivasulu here was instrumental in creating the structural dynamics lab. And then after he left, we created an A-Star lab called A-Star lab, from where I essentially come from. When I look back at what is happening in CBRA to what is happening in SERC, I used to put these figures. Every 5 years, 6 years, this SERC, CSIR-SERC has created a new infrastructure, a very defining infrastructure, including wind engineering and the last one, materials, I don't remember, materials, sensors, mathematics, or some kind of lab like that, so which was created by Dr. NRI and the director afterwards. What I will do right now is, I will talk about something that I thought that I have made. I mean, my own dreams, if I think that I have brought changes anywhere, I'm not going to tell that I have brought changes anywhere. It is that the lab brought changes in me, and that's exactly what a director goes for. Okay? So I have put this as journey as scientist in CSIR-SERC, Roorkee. There is one thing that creates a problem for director, and this lab is one thing which is every director's nightmare as well. Okay? And then everyone will tell you that go there and then hell with you. So you are not going to come back as in a single piece and all that. So that's the kind of thing being told. And if I am in my own dreams thinking that some small changes have been brought out over there, and then the human tendency itself is for growth. You can take from me. It's all like you have a misconception that you don't want to make a change and other things. But the human tendency is, and you have to kindle that kind of thing. Let me go to the, I'll go to this. Yeah, I think it's going. Sir, from the civil engineering perspectives of the CSIR labs, there are 3 labs. There is one more lab called Central Road Research Institute. Everything is created with a model of some big lab, like UK Building Research Institute or UK Road Research Lab, TRRL, and all those things. And then SERC also was created on some model. And then when you look at this Venn diagram of the common thing between CBRA and SERC, and also for CBRA, you will see that building materials, structural fire engineering, then you have architecture. Architecture is not covered in any other lab. And then mechanization and automation. You can't, this way we are a little bit better in our lab, in the sense that naturally interdisciplinary guys have started coming to our lab. There have been mechanical engineers, chemical engineers, chemistry persons, and so many interdisciplinary guys came. But to put them in the direction and make them work is the challenge of the director. And then we worked towards that, and then this is how it was doing. Let me confine to what I tried at a very small level to do that. Like, one of the things, like, every problem is an opportunity for you. Like, the STAR lab, which we inaugurated, I don't know, 2008 or 9, not very sure, or 2007. 2007, yeah, and was inaugurated because of the Bhuj earthquake. Otherwise, yeah, otherwise a very, very dismal kind of earthquake. That was the first urban earthquake that happened in this country. Thanks to the Bhuj earthquake, thanks to the urban earthquake, the Gujarat kind of thing, and then your BRNS. That was the largest BRNS project outside of the nuclear sciences thing. And then we got something like 20 crores or around that. And then we utilized 15 crores. We kept 55 crores for projects, this thing. And the lesson is, every problem gave some lesson to us, okay? Particularly to somebody who is committed to infrastructural engineering and other things. So look for some problem. The problem is your opportunity. That's exactly what you have to look for. One of the opportunities for us is this twin earthquake in Nepal. Any earthquake that comes as a twin earthquake, you will not really know whether it is the Miyagi prefecture earthquake, like Fukushima earthquake, or you have Christchurch, New Zealand earthquake. If it is going to be very devastating, it will be a pair. Otherwise, there will be no pre-tremors. There will be a lot of post-tremors. So this twin earthquake is quite, but it's very damaging. And then CSIR-CBRA, the scientist involved was Dr. Ajay Chaurasya. Some of you may know him. And then we had a lot of meetings. He visited the earthquake site, and then as part of a big group and all that. And then we were trying very hard. After two years of my going there, we undertook, and that gave a large boost to our cash flow. The government looks at the whole thing as not merely publications. Somebody will tell you publications alone is not enough, but if a professor from University of Science or IIT comes, he tells that your publication is important, but then somebody else tells that I should see a visibility and then you should gain your own things. So it gave us a lot of things, and 70 hospitals, very remote areas of the Nepal, and 170 school buildings and 147 hospitals. So we were able to construct. We had some work is still left out, but that gave extreme visibility to Central Building Research Institute. So another thing is makeshift hospital. The one thing that we did, and then SERC also did this, there is a force called NDRF, okay, part of NDMA, who are the ground level forces. We conducted some training and other things to NDRF, ground level forces. And when NDRF was working, any disaster like the Orissa train accident or anything they happen, if it is a pandemic, they are the guys who are going to be affected. So we realized that there was no hospital within the NDRF. I think it is the 9th Battalion in Ghaziabad. So we made an investment of 15 or 20 crores at that point of time. So we will be building this hospital at our own lab reserve and then keep it going. So SERC also did, parallelly it was doing that, little bit later it came. And then Mantriji inaugurated that on Ganesh Chaturthi day. And that was around the time when the first peak was going to hit the country, like around, I don't know, September middle of 2020, around 1 lakh cases per day we were thinking. And then many of them jumped, including, I'm not blaming anybody, but then DRDO, everyone were doing that. They were going for a large German hangar kind of things and other things. But what happened is, they thought that this is going to be, they went on what is called as a rental mode. We put them like it is going to be in a mode where it will be fully with you. They went on a rental mode, and after 1 month, after the first peak came out, the whole country was very happy there is going to be no second peak and all that, and then started dismantling everything. They were all, I think, Safdarjung near the airport in Delhi, there was a huge facility, but then got dismantled. And I don't know what kind of impression the politicians get about that. The PSA warns the Prime Minister, is warning the Prime Minister that there is going to be a third wave, but then we have not warned them enough that there is going to be a much more lethal second wave. Lo and behold, you have to wait for only 8 months. By April, we were hitting something like 4.1 lakh cases per day. But then something providential happened for this lab. So we started building up. They were all like beyond September, October. September was a free lab gift from CBRA to the NDRF, who are actually sacrificing their lives. But then on the aftermath, we started building, and then all these, starting with just a 10-bed hospital to something like, I don't know, 700, 800 beds all over the country, including Himachal. In Himachal, you can't go from one place to another, including Punjab. In Punjab, when we were doing the time given was 4 weeks, we had a competition with IT Madras startup. We just went ahead of them by 5 days or, I don't know, maybe a week or something like this. And each of the hospital has to be a wholesome turnkey. You can't tell that I do not know what is the oxygen 7 liters per minute or 20 liters per minute, and you can't go away shying away designing the duct for the oxygen, including air conditioner, including everything, except possibly some costly medical equipments like portable ECG or portable, some kind of instruments like that. Everything has to be available such that they come and occupy this. This gave us extreme visibility to this institute. You will see here the Honorable Vice President, the Chief Ministers of 3 of the states, Punjab, I think the left below is the Punjab Chief Minister, and the left is the Health Minister as well as Science and Technology Minister at that point of time, and then the last is the current Health Minister as well as Himachal Chief Minister. This gave us in a totally different sphere. So basically it is like this. As the director's plate, you have to close the whole lab, and you have guys who are supposed to work from home, but you really can't check whether they are working from home or they are not working. And then those 4 or 5 core group whom the director takes and then ask them, come with me to this lab, come with me to Safdarjung Hospital, come with me to Ram Manohar Lohia. The family is castigating them. The family is telling them, get lost. You are going to bring. So luckily, I didn't have a family living with me, so I didn't have anybody telling me like you should not go away. And then I was free. Even if you are not coming, I am going and doing that. So this is exactly the philosophy you get. So you are not going as like it is not Jagadguru or Vishwaguru. You are not teaching the whole universe. The universe teaches you. So you are not the director, and you will be directed by all those 250%. Better take it and run this institute. If that is the attitude that's coming, the lab actually, the progresses extremely well. Then the other one which came close on the heels is Ram Mandir. There's a finite element analysis as well as the geotechnical engineering that we have done. We came directly on the lens, on the radar of the Prime Minister himself, and Nripendra Mishra, the previous cabinet secretary, or the architect of our the GST as well as demonetization and all that. He was directly phoning and then taking one-to-one. This is a 10 crore degree of freedom finite element model and all that. It's a beautiful structure. And then 171 feet tall and 100 meters in the length. And then it had a Jaeger mode, which was east-west it was facing. The Rama is facing east, and the other direction has got a smaller width. You can rightly guess north-south is going to have a mode shape. Yes, the north-south had a mode shape. And then the philosophy is not about just, there are three things. It's a masonry structure. It's a special stone brought from somewhere and all that. And then it's not fully granite, it's not a granite. You can do finer architecture and other things using this soft stone. I'm not remembering the name, the place from where it is sourced. You can make fine carving on this particular kind of thing. And the philosophy is not just, there are three philosophies you follow when you are doing a non-monolithic structure. You bank on three things. One is the pure compression stress field, then the friction, then you have occasional interlock. Okay? And when you cut a plane through the weak kind of thing, and then check out all those columns, and then see what is the kind of thing, it is not just middle third, or it is allowed to lift, it is allowed to rock. Somebody here will understand what is the difference between the hysteresis and the rocking. You have a stress strain curve which goes like that and comes back. That is rocking. Like when you are standing, I am pushing you from the back. Your toe or the front portion will get into compression. The back will lift, but you will still have a stability come back. Okay? That's a kind of thing that you need to have some kind of innovation coming onto that. So we started doing a little bit more on that. And IIT Madras gave us the earthquake zoning. Basically, it was in, I remember, I think it was zone 3. Ayodhya was not seismically very vulnerable, even though it is close to Nepal border. Nepal had a serious earthquake. It was quite, and on our map it is zone 3. We put figures in such a way that it went up to zone 4, like Delhi and Patna and other places. So we did a good work, I think, on this, and as soon as Rama came to our thing, everything good happened. And rural housing has been the forte of Central Building Research Institute. This particular, this document called PAHAL. PAHAL means, I think, initiative, or I know some, this thing like that. And then the Prime Minister inaugurates this at Agra with 130 designs. Do you know the cost of the housing that comes out of this? You wouldn't even imagine 400 rupees per square feet. And please compare, if you have to buy a flat right now in Ashok Nagar, or I will put one step beyond, if you have to buy a flat in Noida, happening place in Delhi, last 10 years or something, you will pay something like 20,000 rupees per square foot. Okay? Here is a cost which is 400 rupees per square foot. And then up to the sill level is a very normal design, and beyond the sill level is a locally purchased. And this thing called Pakka Kacha kind of a definition of Pakka has to be functional for 30 years. You can't dismantle and make this thing. And then put every provision such that these guys who occupy that can do a lot of enhancement, can do a lot of modifications after that. That is how the aspirational family becomes. The aspirational family does not want to do a small thing and get away with that. Okay? It wants to occupy, it wants to put it for rent and then put other things, and you should have a provision for that, and 130 designs. So this has been done by us as well as the ROOTAG IIT Delhi. We did a lot of work with an architect, and then that was quite this thing, encouraging to me at this point of time. Another one is the shear wall fire performance. For hardcore structural engineers, we do one thing. If a structure has to perform well for 3 hours, 2 hours of fire, you do one thing, come here, keep increasing the thickness of your shear wall. Shear wall is a large aspect ratio column, sir, so which has a larger depth and a smaller this thing. And whenever the forces in one direction is very large, as in the case of earthquake, you will construct the shear walls, and the shear wall is always a savior for an earthquake. Okay? But then 150 mm, 170 mm, we did a lot of tests. We did the first time in India structural fire engineering tests for shear walls with 300 tons of in-plane load, with 300 tons of in-plane load with a fire loading from one side, and the dishing or the P delta effect of the dishing that is happening because one fiber is expanding, another fiber is contracting, something like 3 inches. So that creates a tremendous amount of moment. Shear wall was not failing, but the fire is penetrating through. What is happening is what is called as explosive spalling. The water vapor that builds up, any concrete or cement that you use is not a solid chemistry that is there. It's only hydration chemistry. When you have cement as a binding material for fine aggregate or coarse aggregate, the cement only does your calcium oxide or aluminum oxide or whatever, iron oxide and then silicon dioxide, SiO2 and all those things. They become calcium silicate and a H2O gets added. 3.5 times H2O, okay, or 3.7 times H2O gets added. So that's simple hydration. And when you start putting them into fire, all these buckets and buckets of water comes out of it. These buckets and buckets of water that comes out of that creates a pressure, and then the pressure has no way to come out of that. They start doing this tap, and then, so you put a IR camera and start watching, you can definitely tell here is a red patch that is coming in my IR camera, this is going to explode and the fire is going to come out. Yes, it did. So that's some interesting experiments, and it is counter to your intuition. You think the 170 mm will save? No. 100 mm is not failing. 170 mm is failing. So this is what a scientist is always looking for. Like there is a saying that civil engineering is the oldest engineering, and then you compare it with, I used to compare it with this. There is a literature, there is a grammar. Okay? The grammar does not, for any language, the grammar does not come first. It is the literature that comes first. That actually tells you this. Your practice comes first, more so in civil engineering. In your semiconductor, I will not tell this. But in civil engineering, I will rather construct an arch and see that it works after 100 years. And I am a mason. My son is also a mason. Not a bad idea. But then everyone is a mason. I understand it is in my blood. And then I will have the dimensions in my blood. I will construct it this way. Okay? So we had time to do that. But now we do not have the time to do all those things. So where the intuition becomes contrary to your intuition tells you have to go this way, it runs contrary. So that is exactly where the research of CSIR-SERC CBR. So this is something that gave us a lot of satisfaction. And then we also created something like a design tool for this. One of the young PhD students was working on that. We are working on it. Now, tunnel engineering is extremely important. We call them as underground space. Okay. Whenever you go 7 meters down, we had a lab in A-Star lab which is 7.62 meters down, and our creep and shrinkage facility was to be created. Our director NRA decided that we'll keep it here for the simple reason you will have the vagaries of, in summer I will go and put a chair and relax. It is still cool because I am 7, 8 meters down. There is a air that is going through that and creating a thermal kind of thing. But then you still have a cool. So 7 meters, 8 meters down on an underground space, you don't have a problem of air conditioning. But what they are doing in Ladakh right now is to store their vegetables, tarkari, this, that, and all those things that they are using that for. And then a marginal cooling is required at the place. So why not construct a space 8 meters down? So Ladakh is something very, very peculiar. Largest radiation of the sun's radiation comes at a very high intensity there. It's a cold desert. It's called as a cold desert. And then the difference in temperature that you experience is extremely large. Something like 35, 40 even, and then minus 40 during winter. Phenomenally harsh kind of thing. So all the analysis and other things have to be done. And then this is one thing. The chief guest was telling about the prefab thing. The prefab has been in our this thing for quite a long time. But what happened is there was an earthquake in a place called Armenia in Russia, and the Russians were too good in prefab because of their Second World War or the pre-World War kind of things. And then they constructed extremely large. And then L&T initial version, all these Besant Nagar flats, all of you know this. Besant Nagar were large panel structures. And then wait for an earthquake to happen, the Armenia it happened, and then every prefab houses came down without like any deformation or yielding or anything. All those elements were falling onto the ground. Imagine that's exactly what is happening even now. That's exactly what is happening. So unless we bring monolithicity, unless we bring proper research onto that, your prefab will get it a problem. Now that it is fine, your wealth is getting generated in the western part of the country, Hyderabad, Bangalore, you build. That's not a problem area. That's not a seismically very vulnerable. But if you go and do that in Delhi, we were in a quality control for Delhi for a great prefab company. I will not mention the name. And in midway, we just walked out. We are not going to do quality control because this is like a sword on your head. I'm not going to control because if there is an earthquake, this fellow is going to run into problem. So that's exactly what. So we created a construction park. I'll go back to that construction park where we asked some of our students. That is the mass housing. We asked each one of you will have an idea. We will support 15 lakhs or 20 lakhs or whatever, and then give a vent to your idea, start making your own prefab. The housing is such a varied kind of things. It is not just reinforced concrete, fill it up with brick. It is actually cold form steel. There is a company called Tata Blue Scope and all those things. So you imagine everything, and then through a shop floor you make a drawing, and in the field it gets in a form in which you assemble that within a week or something like this. Okay, and the weight is also reduced. 1/3 the weight gets reduced, and a lot of advantages. Precast. We made a bamboo structure there. We also made a zero net energy building and all those things. So I'll go to the next one. So zero net energy building. The concept is actually good. What we try to do there is in our net zero energy building, we try to introduce an insulator in the walls as well as in the roof. The roof polyurethane foam and then polystyrene kind of insulators in the floor, and then any net zero energy building. So I have an area this area will generate this much amount of solar power for me, and I am going to consume that. No, that's not net zero energy building. Your comfort days, even without any air conditioner, any kind of gadgets, should be good enough. You will not have a tendency even to switch on your air conditioning for majority part of the time until during peak summer or something you do. So that is actually, it's called as comfort days. The comfort days have to improve. And then what we try to do is this. We try to work on 3 or 4 philosophies, including imagine that you have a fan. Imagine that you have a desert cooler. Okay, starting from just fan. You have a desert cooler, and then the desert cooler increases the humidity in the room. You have a desiccator, which takes away that a gel. It's a silicon gel which takes away that atmosphere and this thing, and then convert that back to the water. So So solar power is used for cooling. Little difficult to understand. The solar power is used for heating those gels, those desiccators, which would have absorbed a lot of water vapor. Otherwise, the cooling efficiency at 100% humidity level reduces. So starting from that, the people are working on that. We thought that we will make a breakthrough somewhere here. And the last one is your geothermal. Geothermal, it's not geothermal energy. It is geothermal cooling, where you have the refrigerant cycle. Generally, an air conditioner, it is called the heat pump. The air conditioner or refrigerator is called as a heat pump. You pump the heat from inside of the room, which is at a low temperature, and pump it out to a outside thing, which is a higher temperature. From 25 degrees, you are pumping it to 40 degrees. At a level which is slightly larger than 45 degrees, such that heat dissipates. There is something called coefficient of performance. Do you know the coefficient of performance of some of the heat pumps? Coefficient of performance means if you have to remove 10 joules of energy, heat energy, you have to spend 15 joules of electrical energy? No. 10 joules by 6, 5 or 6. Interesting, right? So you need to study the thermodynamics of that. So the coefficient of performance of any heat pump, like your air conditioner or something, is a value which is more than 1. So don't get confused that energy has something, you started creating energy. No. It's really a loss of energy, but something gets unaccounted for in this whole thing. So this kind of thing, if you have the refrigerant loop, you have the circulating air loop, we will create another loop which is the water going to that, and have the refrigerant or have this thing rejecting its heat not at 45 degrees outside, but to a well which is still 25 degrees. So your efficiency improves. You have a well in your home which is always evaporating, which is cooler than the atmospheric pressure by 7 degrees or 8 degrees, and then the efficiency improves. So these are all some of the things that we try to do. I will, this is something something which we got involved. There are a lot of things, like I will not go to the details of that. In Varanasi, there is a twin gird, there is a bridge like that, there are 5 girders. 2 of the girders suddenly fall, and then they are attributing that there is a big cyclone and all that, create a lot of stories around that, and then you have to go and prove where exactly they have made a mistake. So it's actually an inverse problem. If they had interconnected, it would have stood. They are not interconnected, very, very sorry to that. And then a lot of other things that we have done. Here is a place, all these things like 20%, 30%, like a number of persons dying in a railway accident, here is 20, 30%. There is a detailing that is missed out at the crust portion of that, and then DG calls me in the evening or night and he tells Gopal, why don't you look into that? And then we go and look into that and solve that problem because of a very simple reason, detailing. Don't think that if there is a problem and a civil engineering structure falls, invariably everyone is going to assume that there is a lack of quality. Okay? There is less materials being used. It's not that way. It is more materials being used here, and that's exactly the problem. And then detailing is a problem at that place. I don't know, I'll put this. Detailing is a problem here. So maybe I'll stop here. Maybe I take a lot of times. So we had a jump in our ECF because of Nepal project. And then publications improved. Everything, like if people think that they are very, the confidence comes in them, everything improves, including the publications. I am stopping with this. I am very thankful to the director for having given me this opportunity because he is my guru's guru. So what do I call? So GSR is the best privilege that I would have had in my life to talk about this person, whom I have seen, but I have not interacted much. And Dr. Srinivasan is here. He tells us extra large number. Every day he starts with a story with GSR. I know that. So in our younger age, he always tells, have you, this new publication has come. I am telling about stories which is 30 years back, 35 years back, sir. So here is a publication that has come. Have you gone and seen Dr. Srinivasan? Why don't you run and see that? So that is the kind of visionary that he was there. So our kudos and then namaskarams to him. I am very thankful to the director. I am thankful to everyone for hearing me. Thank you.
Thank you, sir. On the occasion of our Foundation Day, you have enlightened us of the work done by all the pioneers of CSIR-SERC and also sharing us your own experiences in diverse areas. To express our heartfelt gratitude for the presence of our chief guest and guest of honor for spending their valuable time with us, I request our director to present a memento. Thank you, ma'am. I now request Dr. G.S. Parni to deliver the vote of thanks.
Good afternoon to all of you again. It's my pleasant duty to propose the vote of thanks for the CSIR-SERC Foundation Day function on behalf of the organizers. First of all, we thank our chief guest, Professor V. Kamakoti, Director IIT Madras, for taking off from his busy schedule to deliver CSIR-SERC Foundation Day special address. I am very sure that all of you will agree that the address delivered by him on advances in structural engineering was very relevant and useful for the benefit of society at large. Aspects covered by him such as the structural health monitoring, indigenous development of sensors, cyber physical systems, the green and sustainable buildings, forensic engineering and damage reduction, digital technologies and virtual simulations, the building information modeling, and the digital twins, AI and ML have been very interesting, and these are some of the areas where CSIR-SERC also started working. The equations given by him, simplistic equations like CPS plus BAM equal to construction 4.0 is a thought-provoking equation and gives a new aspects. Thank you very much, sir. We also thank our guest of honor, Professor Nagesha Iyer, Dean and Professor IIT Dharwad and former Director CSIR-SERC for delivering the Professor G.S. Ramaswamy Birth Centenary lecture. The lecture delivered by him is an eye-opener and touched upon many aspects like the establishment of SERC by Professor GSR and its outstanding achievements, different shell configurations and its implementation, deployment in various structures of CSIR-SERC buildings, Technology Vision 2047 and the roadmap for achieving the same, the phase-changing materials and materials with targeted properties. So these are very interesting aspects. Thank you very much, sir. We also thank Dr. Gopal Krishnan, former Director CSR CBRI, Roorkee, for delivering the Professor G.S. Ramaswamy Memorial Lecture. Dr. Gopal Krishnan highlighted many aspects like the multifacets of laboratory developments, the CIA team of Civil and Infrastructural Engineering team of CSIR, and the contributions of CSIR CBRI in national building exercise, especially the reconstruction of the schools and hospitals in Nepal during after the twin earthquake, and the Ram Mandir temple, and the interventions against the COVID-19. Thank you very much, sir. We also would like to thank Dr. Anandavalli, Director CSIR-SERC and Coordinating Director CSIR-CMC, and Dr. Bharat Kumar, our Advisor Management CSIR-SERC, for the constant support and encouragement given for the organization of the CSIR Foundation Day function. We also thank the heads and teams of BKMD, SHRDD, ICT, Audiovisual, Administration, Finance and Accounts, Stores and Purchase for the necessary support. We thank the press and media for the nice coverage of this function. Thanks to Mr. Ramya for scientists for nicely comparing this function. Finally, we thank one and all who have contributed for the successful conduct of this CSIR-SERC Foundation Day function. If we have missed some names, it is not it is unintentional, and we may be excused for the same. Thank you. Thank you all.
Thank you, sir. This brings us to the end of today's function. I thank each one of you for making this event a grand success. Let us all rise for National Anthem.
मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे